Hi guys, what's up? Welcome to this tutorial. In this tutorial, we're going to learn how 7 segments work, and also we do a small and simple and also interesting project which uses only a 7 segment and 3 LEDs. So let's get through it. Let's say, what are 7 segments? We're not going for too much details. Just assume that there are LEDs. Look at here. There are 7 segments, which is the main reason it's called 7 segment. There are 7 segments of LED. So it simply contains 7 LEDs, and we show numbers with these 7 LEDs. So, for example, assume that we're going to connect 7 LEDs to Arduino to show numbers. In this point, we need 14 pins to connect the 7 segment to Arduino. Why? Because each segment, each LED has 2 pins, one cathode and one anode. And so it's 14 pins. It's too much pins for Arduino, especially boards like Arduino Uno that doesn't have many ports and pins. So what's the point? I'm going to say, for this problem we should use something that the pins are going to be less. We have two types of 7 segments. The first one is common cathode and the second one is common anode. In this project, I'm using a 7 segment in the type of common anode. What are the differences? It's not much differences. As I said, the problem is we don't want to 14 pins to connect to Arduino. It's too much. So what we do is simply connect each of 1 pins of each LED together to avoid using 14 pins. In this way, we're going to use 7 pins for 7 LEDs, which is very good. It's half of the pins in the default one. So here I'm using common anode. So the anodes of each LEDs are connected together and connects to VCC. And the cathode pins of LEDs goes to pins of Arduino and controls the numbers on the 7 segment. So with this little trick, we lessen the 7 segments connecting pins from 14 to 7. And what are the other pins? So, as I said, A, B, C, D, E, F, G. These 7 pins are for showing numbers and are for the LEDs. And we have 2 VCC here. Why? Because, as I said, this component is common anode. So in this schematic, as you see, the anodes of each LED connected together to VCC. So this pin that contains all the anodes of each LEDs is here, one in the upper side and one in the downside. It doesn't matter which one of these you connect to Arduino, to battery or 5 volts of Arduino. You can connect just one of these. It doesn't matter if you connect 2 of these or just one of these. And there's another port which is decimal point. We don't need that here because it's used for showing multiple 7 segments when near together. So we don't use decimal point here, and we don't connect the pin of decimal point to the Arduino. So the connection, as you see in the main Arduino and breadboard, is this. A until G goes to pin 2 until 8. And we don't, as I said, we don't connect decimal point pin to Arduino, and we connect one of these pins to 5 volts of Arduino pin. And one important thing here is resistor. 7 segments, as I said, they are simply LEDs. And as you know, LEDs are very sensitive without resistor. So if you connect them to the currents, it should be with a resistor. So here I use a 570 ohm resistor. It's so we have two ways to connect this resistor to 7 segment. You can connect each of these pins to Arduino with one resistor of 570 ohm, or you can simply, as all the LEDs are in the common anode, the anodes are common, so if we just connect one resistor to the anode of all LEDs, it's like we connected one resistor to each of them. So we just need one 570 ohm resistor for the 7 segments. So be sure you surely connect the resistor before you plug into battery. They're so sensitive. Here we have two methods of showing numbers on 7 segment. I'm going for the first one, and in this project I use the first one. So let me explain the first one first. We have a table here, which is 7 segment number table. For all the numbers that can be shown on the 7 segment, there are 7 pins. So with just controlling these 7 pins on 7 segment, we can show each number. For example, as you see in traffic lights, number 8 of 7 segment, when it wants to show number 8, all of the LEDs of 7 segments are on. So when we want to show number 8 on 7 segment, we put all the A to F segments on. And as if it's here's a difference. If you're using a common anode 7 segment 2, in this checklist, if I say you should turn on, for example, A segment, if it's common anode, you should turn off that segment. It's inverted. So in this table is for the common cathode. If the 7 segment was common cathode, we should put 1 to all the pins of 7 segment. But because here I'm using common anode 7 segment, I put 0 to all the segments of the 7 segment. So it's just inverted. But this table is for common cathode, and as it's more logical and we see this logic more common, I use this table here. So as you see, you can show numbers, any numbers from 0 to 9 with just turning on and off each segments with the pins dedicated to them. It was the first method. The second method is using a encoder. Here, if you want to use a encoder, I personally use SN7447 IC. What this IC does is instead of controlling the 7 segment numbers with 7 pins, it does something that it's going to use just 4 pins. And let me explain how this IC does that. We have a BCD table here What is BCD? Is binary coded decimal. It's just the decimal number that's converted to binary numbers. It's nothing much special. So we have four inputs A, B, C, D, and 7 outputs, which goes and connect to 7 pins of 7 segments. And let me explain more. So these F, G, A, B, C, D, E ports are outputs and connects to A, B as the same character to the 7 segment. And the 4 inputs, which is A, D, and C and B, are connected to Arduino to controlling this IC. And we have a VCC and ground that connects to VCC and ground of the Arduino. And we have these 3 pins. You should always inactive them. And how to inactive them? Just simply connect them to ground. No, VCC, because they're all active when they're connected to ground. And if I want to explain a little bit, LT is light test. So for example, if you get this LT pin 0 value, all the segments which connected to this IC turn on, and this as is the name, is for testing the 7 segments if they're going to work or not. And these 2 pins, if we send 0 to RBI pin and also ADCB, which means all the inputs of this IC are 0 to, all the segments of the 7 segments turn off. And this pin has 2 states. One is BI and one is RBO. If we want to use BI, it's like RBI. So for example, if BI value is 0 and also all the 4 inputs are 0 too, all the segments on 7 segments turn off. And if you want to use the RBO state, so if RBO pin is 0 and also RBI pin is 0 and also 4 pins which is out inputs of this IC are 0 too, then 7 segments turns off. So we don't need any of these 3 here. So for inactivating them, we use these 3 pins and we connect them to VCC, and we don't need any of these 3. So it's the pins of the IC which I explained, and it has nothing more. But in this explanation, I explained the 7 segment. As in this project, we have 3 LEDs. After pin 8, we connect the 3 LEDs to pin 9, 10, and 11. And each of them with 330 ohm resistor for safety. Yeah, that's it. Thank you for watching. Let's go for the next part. Hey guys, welcome to the coding part. So let's see the code and I'll explain that. At first, I just defined the pins of Arduino which are connected to the segments of 7 segment. As you see, for example, I defined the A part of 7 segment is connected to pin 2 of Arduino and so on, and then I named the LEDs as their pin 9, 10, and 11, and the name are green, yellow, and red. Then in the setup, as you know, 7 segments are LEDs, and LEDs always defined as output. So here I wrote F4 for simply defining all of the pins of 7 segment as output. It starts from 2 because the first pin is connected to pin 2, and the last one is pin 11, so the 4 should be from the pin 2 until the pin 11, and all of them should define as output. Here's the setup. As you see in the loop part, I defined how they should show up. For example, these 3 lines just shows which LEDs should be on at the same time and which LED should be off. Then, as you see, there are some functions like show 8, show 7, show 6. So let me explain these functions first, and then we're going back through this part. So here at the end of the program, I define some functions to show the numbers. For example, the show 0. Let me draw A, B, C, D, E, and F are on, and G is off. Here is inverted because I used common cathode. I used common anode. So if you use common cathode, it should be all of the A, B, C, D, E, F on, and the G part is off. Because I use common anode, is inverted, and A, B, C, D, E, F are low, and G part is high. As I talked here about this, all of the functions should be like this number. So I display all of the numbers like this one. So there are 8 numbers, there are 9 numbers in 7 segments, but I use 8 numbers because my program just needed 8 numbers. And yeah, so this was how the functions of show 8, show 7 is working. My program is showing, it has 2 parts. First, it shows the red LED and the other 2 LEDs are off. Then it counts from 8 to 0. Then it delays about 3 seconds, which the yellow LED is on that time. Then it goes to green LED and the other LEDs are off, and it counts from 6 to 0 backwards. And again, the yellow LED shows for 3 seconds and the loop is happening again. So the red LED is on for 8 seconds and the green LED is on for 6 seconds, and yellow is on for 3 seconds without showing the numbers. Yeah, it was that simple, and I explained the code full complete. Thank you for watching. Welcome to the next part. In this part, we're going to see how this project works. So, this project called traffic light. Why? Because it has a number that counts and a green LED, a yellow LED, and a red LED, which is something similar to what we have in traffic lights in the real world, which indicates the number, the remaining of the traffic light, and the indicator of LEDs which cars going to the next street or not. So I used 8 seconds of red LED remaining and 6 seconds for the whole time of green LED on. at first it turns on the red LED and counts from 8 to 0 backwards, and then it holds for 3 seconds in yellow LED, and then goes for 6 seconds of green LED on. And also, as it's a loop, it's going to again and again. So let's us see how it works. Thank you guys for watching. I hope you enjoyed this video. If you do, click the like button. Have a nice day.